Hello, it's Leslie Meredith, and welcome to the BreakbulkONE show. Today, we're going to talk about innovation and look at it from 3 different perspectives. We're going to look at discovering innovation, managing and growing innovation within a company, and then building innovation. So it should be a really great show. And first up, we've got Peter Jessup, who has worked on mega projects all around the world. And you might have seen in our BreakbulkONE newsletter his story about the Davinci Crane. So I've invited him on the show today to tell us about that experience and see what kind of lessons we can learn around logistics and innovation. Peter.
Thank you, Leslie, for the kind invitation introduction. Many years ago, I started my career in the EPC world, working for in logistics department for a major EPC company, and I was assigned to a Middle East project as the logistics supervisor, and was invited to a post-award procurement meeting with an Italian fabricator who was going to build and deliver a 450-ton, 37-meter long, 7-meter diameter reactor. The diameter was at the head of the reactor. It stood vertically, so it was like a straightforward column underneath. So the terms that had been bought out was FAS Venice, and they pointed out that their plant was right next to a river. So I assumed it was going to be put in the barge and towed down that way. But they pointed out, no, this would actually be put into the river and towed. So that caused me a number of concerns and a series of questions. The first one was, had they ever done that before with something this big and this heavy? And the answer to that was no, but they did not foresee any problems. I asked about the river. How wide is it? How deep is it? Do they have a map that I could look at while I was in the meeting with them? They said, no, they had none of those details. I then asked about the actual towing arrangement, and they said, well, what they would use is small tows, not the ones you normally see in ports, but that one would push from the rear of the reactor, and the other one would tow from the front. So I asked about the tow from the front. How was that done? They said that would be by attaching a chain to the nozzle on the head of the column. I asked if they'd done any calculations on possible stress loads. They said no, but they didn't foresee any problems. My next question, or the next point I raised was, well, do you need permits to do this, to move on, navigate the river, which is normally what's required anywhere? And then, of course, to enter Venice Lagoon and cross Venice Lagoon to Porto Marghera, the main port for industrial cargo, etc. And Venice Lagoon is a very busy lagoon, lots of pleasure boats and even the occasional cruise ship. They said no, but they didn't envisage any. Question I asked was, okay, I've looked at the GA of this reactor, and it's got a 7-meter head, which is going to fill with air, and it's got a 12-meter skirt on the base. So effectively, this would sit upright, and the skirt was an open area in which the interconnecting plumbing pipework would be connected to the column. I said, so that will fill with water. It cannot possibly float level. Even though I'm not an engineer, common sense said it couldn't do that. Their view was, no, it wouldn't be a problem. I then asked, well, okay, how are you going to put this in the river? And they said, we would use our dock and our special crane. So post the meeting, I had a meeting with the project management team and expressed all my concerns. And they agreed I should go to Venice, visit the fabricator, do an on-site inspection, but also in particular do a complete logistics survey of the river and across the lagoon and meet with the port authorities. So I timed it so that I could spend the Friday with the port authorities, and they made it clear, yes, permits were needed for all of that. They were also very concerned and wanted to see calculations when we ultimately chartered the heavy lift ship, lift on, lift off, because in the past they'd had an incident where the calculations were wrong on the ship turned turtle. So on completion of that meeting, they provided me with what I call a little outline map, of this river. And it's path from Treviso. It's fed from the mountains north of Venice. So I then drove on the Saturday to the fabricator's place, which was by the river, so I could see it very clearly. I didn't enter the facility, just looked from the roadside. Saw the facility. I also saw there was an inlet creek. Their facility was by the river. There was an inlet creek. It had a very nice, big, large sailboat moored in it. There was no dock. There was no special crane. So after that, I then followed the route of the river as best I could by road and sometimes on foot to try and find out, okay, how the route that this goes. Now, this river is used by pleasure boats. It's not a major river, you know, transporting cargo around that a lot of us would understand and know. So I eventually found an entrance into Venice Lagoon with lock gates. I think the place was called Porto Grande, I think, 6.6 meters wide. So it was obvious that reactor could not pass through those gates. I mean, it's just impossible. So I carried on following the river south. Now, this river flows into the Adriatic, okay? All right. So south of the lock gates was a pontoon bridge, literally made up of boats lashed together with planks over the top, which would have to be moved. The next place I came to was a place called Jessup. It's very famous in Europe and particularly in Italy. It's a major holiday resort, beautiful, magnificent beaches on the Adriatic, and the river bisected the town. Over the river was a swing bridge, but that swing bridge was so low, you know, with the traffic go backwards and forwards, and people was so low it would have to be opened to let the column go through there. After that point, I then managed to find a tributary which actually led into Venice Lagoon and managed to see what it was like when it was high tide and also when it was low tide. And when at low tide, it snaked like most rivers do. And effectively there were mud banks either side and the water level had dropped considerably. So to stand any chance of getting through there, it would have to be at high tide. And of course, I didn't have the details of the water depth. Nothing seemed to be available. Alternatively, the route would be to take it into the Adriatic, which was a no-go because the tugs were not designed for going into the sea and traveling down the coast to enter Venice Lagoon the normal way. So on the Monday, I visited the fabricator. He showed me the fabrication yard, etc., facility. And I started to talk to him about the concerns I'd raised in the meeting in London and what I discovered since I'd arrived in Venice. I said, okay, we need to talk about these things. But he said, well, let me show you where the dock is going to be. So we went to the inlet creek, saw the yacht again, and he said, no, they're going to build a dock there. So I said, okay, that's a significant piece of civil engineering you're going to be doing. And you're going to have to create a pad big enough to withstand the loads of the crane that's going to go on there and the weight of the piece when it's being lifted and lowered into the inlet creek. I said, well, where's the special crane? So he said, oh, okay, come with me. We went back to the office and we walk into a room. And that's when I became like a tourist, taking masses of photographs of this crane, which hopefully, Leslie, you're going to put up on the screen.
We are. There we go.
So this is actually the piece being lifted, by the way. So I christened this the Davinci Crane. As you can see, it's a vertical column. They built their dock, by the way. This is after everything got completed. It's got hydraulic capability on it, cross beam and 2 orbs. The principle was to pump water from the river up into the orbs, basically into the large orb for the weight to lift it, and then counterbalancing the water to actually lower it into the water. So I was absolutely amazed at seeing this. And as I say, it did look to me like something from a Leonardo da Vinci sketchbook. And I've been to the exhibition of those, and the guy's a genius. And probably this guy was as well, although I didn't realize it at the time. Anyway, we completed the meeting. I went back to London and pointed out all the issues associated with this. And as a consequence, the project decided, because of the risks, because he's now going to fabricate a big reactor, he's going to build a dock, civil engineering works, he's going to fabricate a crane, he's going to have to proof load test it, okay, and all the permits and everything else that was required, and undertake the transit, etc., close Jessup, move the Pontoon Bridge. So the project got very heavily engaged, and that consisted of me from the logistics perspective. We always used to use marine surveyors to work from a cargo superintendency perspective, the insurance cover. They did the calculations based upon the GA drawings I gave them, the weights of the vessel, etc., and they agreed it would not float level. Okay. So we appointed construction people who specialised in cranes and construction cranes and also construction activities to engage and make sure everything's placed. As you can see, since the vessel, this is a photo of the vessel being, or the reactor being lifted into the inlet creek with the river, everything worked very, very well, as I said, amazingly, and moved it down to Venice. It took a couple of days to do it because we had to hold for a specific time to shut Gecko for the period of time the reactor went through there, and also for the right water level in the tributary. Heavy lift load worked well for the ship, no problem at all. Sailed, delivered to the destination and put on site. So when I reflected on this, I was reminded of a sort of quotation of Davinci, which is, simplicity can lead to sophistication. So this is not a sophisticated crane, but very ingenious and very innovative engineering. As I said, this company continues to supply vessels, columns, reactors, excuse me, frog in my throat, for many years. Unfortunately, they're closed now, and have been for some time, to various EPC companies, including the one that I work for. So that's my story in relation to innovative engineering and logistics.
That is great, Peter. What a piece of machinery there. Certainly something I don't think anyone has seen before. All right, now we're going to move on to Joshua Cotton. He heads up the UAV program at Bechtel. So, drones, for those of us who, sort of the common term there. So, Joshua, over to you.
Hey, how you doing, Leslie? Thank you. All right, so my name is Joshua Cotton. I've known Bechtel about 12 years. My role, I'm the operations manager for North America for equipment. As a part of that, I do head up the UAV division. Bechtel started with UAVs about 2015. About April of 2015, we entered the UAV business. I think I can't say 100% we were the first, but I know we were one of the first EPC contractors to receive a 333 exemption from the FAA. At that point, you had to be a licensed pilot in order to fly a drone commercially, which is how I ended up with it. I'd like to think it was something a little bit more, special than that, but I just happened to be the only person that was in the right position at the right time that knew how to buy his license. But to that end, we started building our program, and it's been really interesting. So I'm going to take you guys through a few slides, and when I get done, if you have any questions, let me know. All right. So here. All right. So UAVs. So BEO, we're the Center of Excellence for UAVs at Bechtel. What that means is we support the projects with the type of technology that's out there, the different services that drone companies can provide, including ourselves. We keep up with all the regulations, training, certification, and then we also work with projects on how to implement drones. One thing a lot of people don't understand is that in order to become an FAA Part 107 UAV pilot, you don't have to actually fly a drone. The regulations are 100%, the certification is 100% based around your knowledge of the regulations. So whenever we receive someone on the projects or on site that is a licensed pilot, we have to then train them how to fly a drone. A, how to use it and operate it. B, how to use it and operate it the way Bechtel wants it done. So that's one of the things that my group heads up there. So one of the main things we provide the projects is high resolution, 3D data. You can see down here the little drone going in this little lawnmower pattern here. Basically, that's the typical flight path for a drone when you're collecting photographs. It's pretty simple. Flight planning is pretty simple. It's just a math problem. Figure out how many pictures you need to take to cover a certain amount of acreage at a certain altitude, and the software does it from there. So our main deliverables are high resolution 2D orthomosaics, 3D point clouds, full color 3D models, contours, and digital surface elevation models. All right, so here are some of the use cases. So one of the power the most powerful things about a drone on a project is one flight will serve multiple stakeholders. So we can go out there and we can fly a drone over a project, and we can provide data to safety, surveying, we can provide progress reporting data to cost control engineers, field engineers. We can provide quantities on demand, geospatial information systems. We help with workplace planning, laydown management, environmental site monitoring, and security, all of one flight. So you can imagine it's a pretty powerful tool on a job site, especially when reduced cost is always at the forefront of everything we do. So here's a couple of examples with some of the data you can get from a drone. So, in the past, to get this from a survey crew would have taken a lot of man hours. We can do something like this in a matter of hours. So today, we can guarantee less than 5 centimeters of accuracy, repeatable precision, and it's a whole lot faster and cheaper than a survey crew. I can tell you right now the accuracy is a lot better than 5 centimeters, but we guarantee at least 5 centimeters. Now, will that satisfy every single survey use case out there? Absolutely not. But it satisfies enough of them so that we can keep our survey crews doing what they're good at, which is high precision survey, instead of having to go out and measure the volume of a stock. We don't need to waste a highly paid, highly trained surveyor to go and measure the volume of a stockpile, something like that. We can give you quantities on demand. So again, same day delivery of accurate volumes, visual representation of quantities, confirmed cut and fill estimates, verified truckload estimates, and we can create a historical record that can be accessed at any time. So what's interesting about it is every time you fly one of these, you have a record, a snapshot in time, so that you can go back and look. It can see exactly what the site looked like, exactly where the volumes were. So in case you have any questions or concerns, disputes, whatnot. So here's a use case on progress reporting. So this was on a site where the project wanted to turn a portion of the laydown area into a parking lot. So you can see over time, where we just documented this with a drone, we were able to overlay some basic drawings saying this is about how many parking lots we want, or sorry, how many parking spaces we want to add and whatnot. And again, just track the progress over time. So here you see is the first wave of cars being able to be parked. And there you go. So there's the final product, right? At the end of the day, where we took a laydown yard, turned it into a parking lot. Again, it's not earth-shattering, but it provides valuable data to the project planning and management team. So again, workplace planning. So this is typically what you'd see, right? You'd see this drawing, which, is interesting. If you're an engineer, CAD designer, makes a lot of sense to you. But now you add a picture underneath it. So it just adds a lot of context to the drawing, right? Now you can really visualize it. You don't have to be an engineer. You don't have to be a CAD designer to be able to understand what's going to go where. Some more examples. So this is a program called Synchros that we use. So typically this is what you see. You'd see a drawing and you'd see some 3D modeling here, right? Again, it's useful information, but when you add a drone shot, an orthomosaic underneath it, it really adds a lot of context, a lot of value to it. And again, everybody on the projects love this product here. This is just a quote from one of our tank managers, where he's saying there's a huge positive feedback from the field team in the last couple of weeks. Look ahead meetings were a lot more valuable. So here's an example where we were going to put this. There's about a 600-ton crane going right here. And normally we would just be looking at a CAD drawing, say we're going to put a crane right here next to this vessel. We're going to make some picks, and here's a swing radius. So then when we underlaid the orthomosaic, we realized, wow, we've got a lot of work to do, because currently that crane's not going to fit there. There's a whole bunch of stuff there. So again, rather than go and find out on the day you show up to move the crane in, we figured this out 3-4 weeks ahead. So we were able to, keep the crews busy and, not find out when it's too late. So just more examples of how the different vantage points look when you're using the synchro modeling tools in conjunction with the orthomosaic. So here's a laydown management. This is something we do for procurement, which they seem to be pretty excited about. So this is your typical laydown yard. So from that shot, we can zoom in pretty good and find items and verify where items are. hopefully one day we want to use artificial intelligence to start recognizing these shapes and start tagging them, but we're probably still a little ways out with that. Another thing we do is we take and we fly the laydown yards, and then we have an algorithm that calculates the unused space. So I always liken it to defragging your laydown yard. So we can go in there and, you know, from the ground level while you're driving around, you look around, you see, yeah, it looks like the laydown yard's pretty full. But when you fly it, you realize you might have 20 acres of unused space, and the program will show you exactly where it is. So you can go in and start moving things around, consolidating it, and getting back your space, which in the long run will save the project money, save them time and energy of having to go out and maybe get another laydown yard or whatnot. So it's an efficiency game. All right, so getting here towards the end. So one of the latest use cases we're looking at is inspections. So I'm not sure if this video will play here, so you're going to have to bear with me 1 second. I'm just going to, all right. So for some reason, the video won't play in the regular PowerPoint. So what you're seeing here is this is a drone with a 30 by optical zoom camera on it. So you can count the threads on this bolt right here, where normally you'd either have to boom that machine down or you'd have to use binoculars. And I can tell you, unless you have some pretty high dollar binoculars, you're probably not going to be counting threads. We use this to look at cranes that are up in the air and locations where it's not easy to boom them down and just inspect them for damage. So you can see this is a crane that's in a repair yard where we tagged where some damage was, and we wanted to see if we were able to recognize the damage with the camera. So I think it's pretty impressive. So this, again, zooming in with the 30 by optical zoom, inspecting the cable. So you can see this cable, again, this is in a repair yard. This is not a crane that's in use, but you can see that if it was in use right away, the cable needs lubrication. So it's a good way to know whether or not you need to boom a machine down or not. It's pretty expensive to boom cranes down because you have to have a crew, everybody on the ground. You have to do a lot of coordination with moving the crane into place to boom it down. And then the majority of crane accidents happen when you're booming them up and down because you're changing the configuration of the machine. So right now we're just simulating a cable inspection here. Again, this is at the laydown yard here in Houston. All right, so I'm going to stop that there. I'm going to go to the next one. So the next one here is, this is a 360 immersive view. So this is one of the things that our project management teams find to be the most powerful. And it was actually funny. We kind of stumbled onto this. This is technology that's used in the real estate industry to do 360 virtual tours of property. So we took that technology and we adapted to job sites. So I'm going to click this. It should take me over to another site here real quick. All right. All right. Can you guys see? Okay, good. You can see. All right. So what this is this is one of our repair yards, and so this is a 360-degree panoramic view that we do with the drone. So in the upper left corner here, you see every couple of weeks we send the drone to the exact same spot, same altitude, same lat and long, and we do a 360 photo. So we're able to compare week over week what an area looks like. So we do these on projects as well. I just use this example because, you know, we're not allowed to share that, but as you can see, the resolution is quite good. You can zoom in and you can almost do a safety walk from your office. You know, I mean, I looked through this, and this is a facility that I manage, and I'm just looking through this a few minutes ago, and I'm like, okay, I need to make some calls over there. There's a little bit of housekeeping stuff we need to handle. You know, I mean, the guys are pretty good, but you know, there's always room for improvement. So you can also take this technology, and we can do a split screen. And let's see here, I can go back, say a month. I can synchronize the views here. It's pretty close. Anyway, and then you can lock them. And so then you can scroll around and you can look side by side what it looked like a month ago. And so this is some of our, change detection type stuff where you might look and say, this was supposed to be moved a month ago. That area is supposed to be cleared out. We were expecting this area to be ready to move in vessels or whatnot, right? So again, this is just the yard. Project's a lot more impressive. But, so that brings me to the end. I mean, those are our basic use cases. We have quite a few more. A lot of them we're not allowed to share. It's stuff that we're developing internally, but I can assure you we are working. I think we have around 70 use cases total. So one thing that Meredith asked me to do was to share a couple of drones that we use. So I'm going to get up and hopefully you guys will see what these look like. So chair out of the way here. All right, so this one was our very first drone. This was made by a company called Skycatch. So back in 2015, you actually had to put an N number on the drones, just like an airplane. And if you ever look this up on the FAA website, that N number used to belong to 727. Now belongs to our drone. Again, this was an early days drone. You can see there, a lot of the stuff was 3D printed. The camera technology was a basic Canon point-and-shoot camera that was synchronized to this little cable. A lot of 3D printed. This is a custom-made carbon fiber shell. And at the time, this was a quite sophisticated little machine. What we use today, this is made by a company called DJI. So DJI makes a pretty popular drone, the Phantom, the Spark, and the Mavic Air. So you probably heard of those if you follow drones at all. This is their big brother, the M210. This one is a pretty interesting drone because it provides, this little camera here is the FPV camera. So what that means is while you're flying, you can see out this camera, just like you were sitting in the cockpit of the drone. And then you can add payload here. So we can add a thermal camera and then a regular RGB camera. And we can also put a camera on top in case we need to inspect something from down below. So we can get that view, that oblique view above the drone. We have 2 more drones in our fleet that they're too big to bring in my office. So that's all that I have. You guys have any questions?
Josh, let's take questions at the end. I see that we do have some, but we'll take them at the end. I want to move on now to our third guest, Jake Loosararian, who is the CEO and founder of Gecko Robotics. It's an amazing story, and I'll let him tell it, but let me give you a preview that he actually started his product line of AI-powered robots when he was still in school. Wow. And now his robots are used by oil and gas companies, power companies that are really household names. So, Jake, let me turn it over to you.
Yeah, awesome. Peter and Josh, amazing overviews. It's really exciting to see what's going on in these industries. Thank you so much, Leslie. Pleasure to be on today. A little bit about Gecko, and I would love for the video to be pulled up while I'm talking, just so they get something more interesting in my face to look at. A little bit about Gecko. We make robots that go out into the real world and collect physical infrastructure data to help predict when things will break. So we work in the oil and gas, power, and pulp and paper manufacturing industry. We do some work with the DoD as well. But basically, what we're doing is these robots that you see are climbing on critical infrastructure, things like piping, pipelines, boilers, scrubbers, etc. And at these facilities, and looking for integrity defects that are actually going to cause shutdown of the facility or just a lot of damage to the assets themselves. Obviously, these assets are worth so much money, are being served so much. And the current, and what I found when I started this in college back in 2013 was that the current way of doing inspections that dictates so much maintenance workflow as well as CapEx budget and downtime are being done by humans in these kinds of environments, and they do an amazing job. But it is a unsafe at times job to do by hand. It also, unfortunately, does not capture very much data, and that data is very hard to make repeatable. And so what the robots are basically doing is solving some of those core problems. We're taking a job that's really unsafe and empowering humans with technology, with these kinds of robots. And if you can play the second video too, that'd be awesome to kind of like pull it all together of where the data goes. We're collecting about 40,000 times more pieces of data and doing it 10 times faster for our customers like Exxon, Dow, Chevron, Marathon, BP, Duke Energy, Southern Company, Georgia Pacific, these kind of large companies. We are going out, the robots are going out into this industry, collecting that data, and then we're using machine learning, artificial intelligence to predict into the future when that infrastructure will fail, and also looking at the signals that we're collecting, these millions and sometimes billions of pieces of information that dictate integrity and health of assets. We're using that information to help create insights about why they're failing. And so that's a big part of what we do and how the hardware and software kind of merge together. We are a fast-growing company. We really early kicked off and started the company in a major way in 2016. And since then, we've grown to these 3 industries and are working with these larger companies now. About 4 product lines with robots that can do various types of inspections according to ASME, ASNT, API types of inspections, which are bodies that regulate these types of things. And it's beginning to turn, this tool is beginning to turn the tide on how inspections and maintenance should be done in the industry. And we're seeing a movement to this type of improved tool for maintenance and being smarter about where you put your maintenance dollars. Do you have that second video, Leslie, at all to pull up?
I'm not sure we received the second video. So yeah, just proceed.
Yeah. Sounds good. So anyway, we're backed. We're backed by some really amazing companies that utilize our technology across, in some cases, 50% of the assets that make things happen on this site. And we've actually begun to see about 85% increase in 85% decrease in the amount of unplanned outages for assets, especially in the power industries where most of the data comes from, when using our technology. So basically how it works is you have the robots and a crew that go out from Gecko. The inspection is completed, and then the turnaround of the data itself is then sent out on a product we call the Gecko portal. And the Gecko portal, which definitely encourage you guys to go to the website geckorobotics.com and check out the not only the hardware but also the software technology that enables that enables our customers to go in, look at the information and perform analytics and work off of it to understand where things are failing and why.
Okay, Jake, that is so interesting. That was a great video. I think we'll turn to the Q&A now, but before I open it up, Jake, I do have a question for you. For the inventors and entrepreneurs out there, give us a little insight on how you transitioned from, recognizing this need in college and then bringing it to market. How did you get in front of those big companies?
Yeah, it was so basically I found the problem because an alumni of my school, and I was doing electrical engineering at university. I knew, and he was a power plant manager, and so basically he was running his power plant, and about 40% of the year they had shut down due to infrastructure failure. And so I dug into how they perform their inspections and maintenance, and I found that speed of inspection and understanding the problems is very slow and very costly, because every hour you're down, you're losing lots of money. Second, it is really dangerous. A year ago, someone fell off and died during an inspection at his facility. And then 3, the inspections themselves aren't working. They're not accurate enough, and they keep having 6 to 12 shutdowns of the power plant every single year. So this power plant manager was suffering in a major way and was on the verge of shutting down his facility. So I made a wall climbing robot that could go and do an inspection to identify the problems fast, accurately, to find out what's actually wrong and be able to target the repairs. and then safe, because the robots are climbing the walls and the humans are having to climb on scaffold, use JLGs, propel down with rope, etc. And so it was able to save his facility about $15 to $20 million that year, and save. He said about a dozen forced outages of his power plant. So that's how I knew that there was something to this. But I of course didn't realize how huge of a deal it would be, and the company scale that we've seen to date has been pretty massive. Basically 2x their employee headcount every year since 2016, and the impact that the industry is seeing and the benefits from having a source of truth of information, a standard and a repeatable process that they can go out and continue to do these inspections and make repairs on, is changing the way that they think about maintenance. And it's changing the way that they're thinking about the longevity of their assets. That these, instead of replacing a tank after 20 years, they're now looking at how are we fixing this and what is causing us to accelerate damage, and how do I change that? And how do I make this tank last 40 years? Or how do I, or what variables are causing it to be operationally deficient? And so getting to the place where we were doing that for these humongous companies was basically just you have to live the problem. And so I've spent the last 8 years basically living at refineries, power plants, and manufacturing sites. And so it's just the kind of engineering it takes it's boots on the ground. And my colleagues on this interview completely understand that. It's you do not get to solve the problems unless you understand the problems that the customers are facing, and that drew us to engineering on site. So our engineers would spend the majority of their time building the technology, building the robots that can climb walls and the software that can enable that, as well as enable the analysis of the analytics and the data. They would go on site with hard hats on, with FR clothes, with all the PPE required, and they would be running the technology. Our engineers with advanced degrees from SpaceX and Tesla would be out at these sites doing that work to understand the failure modes, to understand what the customers really wanted. And so that's what the company is all about. We should not exist unless we're solving a huge pain point for our customers that makes their life 10x better in some capacity. And that's what we've stayed true to, and that's why we've seen such massive adoption from these large companies, to the point where we're now getting nested contracts with some of these companies.
That's great. Oh, okay. That is really interesting. I think you bring up a number of good points, particularly about knowing your customers, what they want, and also the technology side of things. So that is really interesting. I want to circle back to Peter. When you saw that crane, clearly that was a one-of-a-kind kind of thing. You hadn't seen it before. Certainly there were safety issues that must have come to mind. What kinds of things, if someone sees innovation, someone sees something new, what kind of vetting process should they go through before actually using it in a job?
Okay, so I'll speak specifically to the example I've given. In relation to that, obviously, of course, the classic thing you do with any crane is you've got to have a safe working load, load testing. But the other thing that we did was heavily engage in not just the normal inspection and engineering interface regarding the fabrication of the reactor. We actually engaged in that in relation to the fabrication of the crane. The other piece also was we used our construction people who have expertise in cranes to actually work with engineering as well in relation to how the feasibility of that working and what the mechanics of that would be. Okay, and similarly with the dock that they constructed, that was done on the basis of making sure that, as I said, there was a dock and that actually the pad that was installed from the civil's perspective, all the calculations were done in relation to that and reviewed and bought into. So I guess the bottom line is if you see something that's very unusual, and I would look at what my two fellow presenters have presented, which was fantastic, unbelievable, is I believe that the classic thing in all that is you have to really do a deep dive on these things to fully understand it, identify what the risks are, what the probabilities are of success, and then work out how you're going to put a risk management process in place and address it from a technology perspective or a sheer interface and execution activity.
Okay, great. Josh, let's we're kind of running out of time, but we do want to know, our viewers want to know, what, as you look forward in your UAV program or UAVs at large, what features do you think may come about in the future? New uses or new features of the machine itself?
You know, with UAVs, it's very similar to kind of Jake's field there, right? I mean, they're basically flying robots. So the different types of sensors you can put on a UAV to collect data is really what we're looking at, right? I mean, we're looking at LiDAR sensors, thermal sensors. The primary sensor we use, if you will, is just a RGB camera today, right? But it's really about sensor technology. The drone as a platform that flies is pretty robust. I mean, more probably collision avoidance type technology and sensors could be used. And they've been doing a pretty good job of developing most of that. Lots of companies are using AI to help define flight paths based on, you know, say CAD drawings of different areas. So these things are able to navigate more and more autonomously. That's really where the value comes in these drones, is being able to let them work autonomously, right? If a human has to sit there and fly it, you can still mitigate safety. You can still do a lot with them, but like I said, the true power, the force multiplier comes in automation, right?
Okay, great. All right, well, we're going to wrap up in a minute, but I just want to go around. We'll do Jake, Peter, Josh, same order. For viewers that in the industry who are not engineers, who are not mathematicians, who don't have perhaps your technical expertise, but all three of you have a very open mindset that is open to innovation, is open to change. What advice would you give colleagues to develop that sort of innovation mindset? Jake, that's you first. How do you develop that? I mean, obviously it comes naturally to you, but for someone that finds it a little more difficult to deal with, how can people feel more comfortable with technology?
Yeah, I think technology can sometimes be a stumbling block for figuring out the right problems. So I think I wouldn't necessarily say like anything, like there are mental blocks that cause good things to not come to fruition, right? So like if someone's doing X-ray scans of some piping or a weld, like there are processes and steps to improve the acquisition of the information. And like, don't use that example like to its fullest, I guess. But I think what I'm trying to say is whatever is most valuable for the customer, improvements on that thing is where innovation should stem from. Like, there's no point in going out and creating something just to create something. That's what entrepreneurs do. Go out and create something that's actually useful and has data to back up why it's useful to the potential person you would sell it to. It's basically like, don't make something that like you'd rather have 10 people love the thing that you made than 10,000 people who like it.
Okay.
Because people who love it will tell their friends and talk about it. People who like it will forget about it.
Good advice. Okay, Peter, you've got obviously you showed us through that case study or your experience that you are open to innovation. How would you encourage others to feel more comfortable with technology?
Well, I think when I reflect on it, that question is a good question. I think probably seeing that crane for the first time and then seeing that it worked, I think created a change in my mind, because I told you initially my reaction to this is never going to work. This looks a bit Mickey Mouse to me. But it worked, and it did. And what it demonstrated to me is one's got to keep an open mind on these things. But what you've got to do is, wherever that innovation is coming from, you've actually got to dive into it, drill into it to really understand the feasibility of what is being proposed and the value it brings. Now, in this case, it was just lifting a column. But if I look at the other two presenters here today, I mean, that's pretty significant what they're doing. And I think it's about, will it work? How does it work? What does it take to do it? And as I say, from that moment onwards, I think that probably helped to create a sea change in my mind about what innovation can be. And of course, compared to when I did that, compared to now, innovation is everywhere. Technology has moved on so much. So I think it's keeping an open mind, not having a closed mind, but being careful.
Okay. All right. Josh, we'll wind up with you. You're certainly immersed in technology, and we know that Bechtel is a leader in innovation. How do you bring more people into that innovative mindset and willing to embrace technology and change?
Really, kind of two ways. I mean, Bechtel's done a really good job of driving change from the top down. Our CEO is very passionate about innovating and making sure that we're providing the best value to our customers and clients, and also providing safe workspaces for all of our employees, right? So when we look at innovation, we look at to see, is it going to improve a process? Is it going to make the process safer? And at the end of the day, is it going to save the company money, save the client money, right? Like Jake said, you can collect a lot of really interesting but not useful data if you don't watch out. So you really have to go into it understanding what it is you want. But by the same token, don't be afraid to look at something that you never thought would be useful. I remember, honestly, when I first saw the drones come out, I'm a licensed pilot. I love aviation. When I first saw drones come out, I was like, yeah, whatever. They're interesting, And then all of a sudden, it kind of got put in my lap, and I was like, wow, okay, these things are actually really cool, So I think you just, like the other two said, you have to keep an open mind. Don't be afraid to take a chance. But in order to be successful with that, you have to keep an eye on where the benefit is. And you really have to understand the technology, or hire somebody who does understand the technology, right? We can't all be experts, but you can certainly find an expert in the field and partner with those people and have them guide you through understanding the technology and how it's going to help you as a company.
Perfect. All right. Well, we've about run out of time. So I want to thank the three of you for sharing your stories, sharing your perspectives on innovation and advice to keep this industry moving. So thank you so much. Till we meet again, stay safe, and we will see you soon.
Thank you.
Thank you.
Thank you.